working with logs and exponentials. Our first problem is, given f of x equals 3 times 2 to the x minus 6, find the inverse of f of x. Include the domain and range of the inverse of f of x and check your answer graphically. Alright, in order to find an inverse, the first step is flipping our x's and y's. And that's because the inputs and outputs switch on an inverse function versus the f of the original function. This basically means if the point -1, 1 was on f of x, for example, then the point 1, -1 would be on the inverse of f of x. Alright, so in order to find this equation, we're going to flip x and y. So f of x becomes x equals 3 times 2 to the y minus 6. Okay, the first thing I notice is that there's a lot of numbers going on, and I want to isolate y because that is the easiest way to graph it. So I'm going to start by adding 6 to both sides because the first thing I want to do is, if there's extra numbers around y, is do the addition and subtraction first. So 6 is going to cancel out on the right side, and I get x plus 6 equals 3 times 2 to the y. Next thing I want to do is I want to get rid of any multiplication or division. I see it's times 3, so I'm going to divide by 3 on both sides. Okay, x plus 6 divided by 3 is equal to 2 to the y. Now that the only thing that I have on the right side is a number that's to an exponent of y, I can flip this to a logarithmic function to completely isolate y. Okay, so this means that I'm going to have log. Okay, so then since 2 is the base with the exponent, 2 becomes the little number. Since x plus 6 divided by 3 is the number across, it becomes the big number. And then finally, since we're trying to isolate y, that's the number that goes on the other side of the equal sign. And then, since we're finding the inverse function, to finally write the equation, we don't want to write y, we want to write log base 2 x plus 6 divided by 3 is the inverse of f of x. Okay, so now we're going to find the domain and range. I'm going to start by finding the domain and range of the exponential function f of x in order to find the domain and range of its inverse. Okay, so an exponential function looks like this, with it stretching all the way to the left and to the right. So I know the domain is going to be negative infinity to infinity. The range is a little harder, but every exponential function has a horizontal asymptote where the function goes no farther up or down. In this case, we can find the horizontal asymptote by seeing what number is added or subtracted, which is -6. And this means there's going to be a horizontal asymptote at y equals -6. So I know that the function is going to go no more down than -6, and it's never going to get to -6. But it's going to go all the way up to infinity as it stretches on all the way up. And I know that it goes up because 3 is positive. Okay, now that I have all these numbers, I can flip the domain and range to find the domain and the range of the inverse of f of x. Remember, the inverse just means that the inputs and outputs switch, and domain and range are equal to inputs and outputs. So I'm going to make the domain here -6 to infinity, and the range -infinity to infinity. Okay, so now we're going to find the domain and range. I'm going to start by finding the domain and range of the exponential function f of x in order to find the domain and range of its inverse. Okay, so an exponential function looks like this, with it stretching all the way to the left and to the right. So I know the domain is going to be -infinity to infinity. The range is a little harder, but every exponential function has a horizontal asymptote where the function goes no farther up or down. In this case, we can find the horizontal asymptote by seeing what number is added or subtracted, which is -6. And this means there's going to be a horizontal asymptote at y equals -6. So I know that the function is going to go no more down than -6, and it's never going to get to -6. But it's going to go all the way up to infinity as it stretches on all the way up. And I know that it goes up because 3 is positive. Okay, now that I have all these numbers, I can flip the domain and range to find the domain and the range of the inverse of f of x. Remember, the inverse just means that the inputs and outputs switch, and domain and range are equal to inputs and outputs. So I'm going to make the domain here -6 to infinity, and the range -infinity to infinity. Okay, our final step is checking our answer graphically. Okay, and we can do this by graphing both f of x and the inverse of f of x. Okay, so the first thing I'm going to do is I'm going to make some tables of values in order to find points on the functions. All right, for f of x, I'm going to start by plugging in 1 for x, and I'm also going to plug in 2. Okay, because those are small numbers, so I'll probably get pretty small numbers out. So when I plug in 1 for x, I get 2, and then 2 times 3 is 6, minus 6 equals 0. Okay, and now I'm going to plug in 2. 2 to the 2 is 4, times 3 is 12, minus 6 is 6. So those are the points I get. Now, let's plug in points to the logarithmic function to see, or plug in numbers to the logarithmic function to find some more points. The first point I'm going to plug in for the logarithmic function is 0. And I chose 0 because I know when I add 0 to 6 over here and divide that by 3, I'm going to get 2 out. And that's important because I know that log base 2 is going to be equal to 1, which is a relatively easy number to solve. Or a relatively easy number to find. So I'm going to get 1. It's not too big, it's easy to graph. And if you notice that 1, 0 is the point on f of x and 0, 1 is the point on the inverse of f of x. And now I'm going to do the same thing. I'm going to plug in 6 this time, though, because I want to get this to equal to 4. So I get log base 2, 4, because that's the next easy number where 2 is to an integer exponent that I can find for. So if I plug in 6, I get 6 plus 6 equals 12, divided by 3 is 4. 2 to the 2 equals 4, so I get this point out. Okay, so the points I get are opposites of each other, so I can tell that these points are right. Now it's time to graph the functions. So I'm going to put the points in. 1, 0. 1, 0 is here. 2, 6. Here. Okay, and the final thing I'm going to graph for my exponential function is that horizontal asymptote at y equals -6. Okay, so here is my exponential function. All right, now I'm going to graph the points for the logarithmic function. Okay, so I get 0, 1, so that point's going to be here, 6, 2, here, and then finally, so since we had a horizontal asymptote at y equals -6, there's going to be every logarithmic function has a vertical asymptote. And this asymptote is going to be at x equals -6, just because the horizontal asymptote was y equals -6. So to flip it for the inverse, it's going to be at x equals -6, which is 3, 4, 5, 6. All right, and now I can draw function 3. All right, and that's how you graph the functions. All right, our second problem asks us to write an exponential function given that f of 1 equals 8 and f of 3 equals 1/32. So the basic form for an exponential function is y equals ab to the x. Knowing this and knowing that I have 2 points makes me think that I'm going to have to write 2 equations plugging in y and x from the 2 points in order to find a and b. All right, so I'm going to do that. So I'm going to plug in, for y, I'm going to plug in 8 for the first point, then a, b, and then x is equal to 1, and since b to the 1 is equal to b, I don't have to write that one. So that's my first equation. Then, same thing. All right, so the first step I'm going to do is I can see that I can, if I divide one of these equations by the other equation, I can get rid of a. So my second step is going to be to eliminate a. And I'm going to do that by having 1/32 divided by 8 is equal to ab cubed divided by ab. All right, a and a is going to cancel out. 1/32 divided by an 8 is 1/256. And then that's equal to 1 over b squared. So b is equal to 1/16. All right, now knowing the information I know, having b, I'm going to plug b back into an equation in order to find a. And the easier equation to do that is a equals ab, because b is not to any exponent. So I have 8 is equal to a times 1/16. All right, I'm going to multiply by both sides by 16 in order to get rid of the 1/16. So then I get a is equal to 128. All right, now I have all of my parts to fill in the equation since I know a and b. So I can write y is equal to 128 for a, parentheses, 1/16 for b to the x. And that's the equation that goes through both of these points.